Alright, so this is question number 12, and here we have to work with a special kind of cell known as the Edison storage cell, and we have to find out several conditions such as the dependence of the cell EMF upon the concentration of the electrolyte, and the maximum amount of electrical energy that can be obtained from a particular substance, and other things. So the question basically says that the Edison storage cell is represented as Fe solid to FeO in a KOH solution, and Ni2O3 goes to Ni. Now the first part of the question asks, how does the cell EMF depend upon the concentration of KOH? And the second part that we have to solve is, what is the maximum amount of electrical energy that can be obtained from 1 mole of Ni2O3, given that we have the E naught of the cell to be 1.27 volts. So Tushar, please take us through this question.
Okay, so the whole cell reaction is given here, and we just need to write the half reactions and we'll add them. Okay, so from this we can write the half reaction as Fe plus 2 OH negative gives FeO plus H2O plus 2 electrons, and Ni2O3 plus H2O plus 2 electrons gives 2 NiO plus 2H2, 2 OH negative.
Okay. Right, so you have to keep in mind that because the electrolyte is KOH, so the OH minus will also play a role before writing the half reactions.
In this cell, it is not easy to write such half cell just seeing this cell. This can only be done by practice. If you practice few questions, you can easily do this. So you need a practice at this point. Okay. Now, in the reaction we see that 2 electrons are cancelled here. Okay, so we get this reaction here. Okay, now H2 is also being cancelled, hence it's not in the final reaction. The first part asks, how does the cell EMF depend on the concentration of KOH?
Alright.
As we see the net reaction, we don't see any OH, that is KOH, as it is being cancelled here.
Yeah, even the OH minus gets cancelled, yeah.
So as the net reaction does not contain OH negative, that is KOH, hence EMF does not depend on the concentration of KOH.
Alright.
Okay. Now for the second part, it is asked that what is the maximum amount of electrical energy that can be obtained from 1 mole of Ni2O3, and E naught cell is given. Okay. So
right.
अब दिमाग में ट्राई करते हैं मैक्सिमम अमाउंट ऑफ इलेक्ट्रिकल एनर्जी क्या है, कि एकदम से आ गई एंड काफ़ी बच्चे सिर्फ इतना देख के सोचते रहेंगे और काफ़ी बच्चे छोड़ देंगे इस क्वेश्चन को, क्योंकि ये न्यू वर्ड इधर दिखता है.
Yeah, this sounds a bit tricky, this question.
हाँ, ये थोड़ा सा ट्रिकी है क्योंकि इलेक्ट्रिकल एनर्जी थोड़ा सा थर्मोडायनामिक्स का कॉन्सेप्ट और इलेक्ट्रोकेमिस्ट्री का मर्ज किया हुआ है, लेकिन ये सिर्फ काफ़ी सिंपल प्रॉब्लम है. इसमें बस ये हमें पता होना चाहिए कि मैक्सिमम अमाउंट ऑफ इलेक्ट्रिकल एनर्जी सिर्फ गिब्स फ्री एनर्जी होता है और कुछ नहीं. Hence we have to calculate the value of delta H, जो हर बच्चे को ऑलमोस्ट आता है. And we even know the calculating formula of delta G, that is minus NFE, क्योंकि हमने काफ़ी बार यूज़ किया हुआ है, अब तक तो काफ़ी हद तक रट चुका होगा हमें.
Yeah, this is a familiar equation. Yeah.
तो अब N की वैल्यू हमें निकालनी है, तो हम हाफ सेल से देख सकते हैं. इट इज़ 2 इलेक्ट्रॉन्स, इसलिए हम काफ़ी आराम से N की वैल्यू लिख सकते हैं 2.
Yeah.
F की वैल्यू हमें पता है 96500.
Yeah.
और E naught cell हमें दिया हुआ है, which is 1.27. Hence we'll multiply these quantities and calculate the value of delta G, which comes out to be minus 2.45 into 10 to the power 2 kilojoules. Hence this would be the maximum electrical energy obtained.
Right.
This was a very easy question, but it was only a bit tricky.
Right, so with this we come to the end of this question and we'll move on to the next one. Alright, so we move on to question 13, where basically we come back to the concept of the spontaneity of reactions and the Gibbs free energy. So the question basically asks, predict whether the following reaction can occur under standard state conditions, the reaction being the oxidation of SN2 plus by Br2. And the half reactions are given, as you can see, SN4 plus 2 electrons gives SN2 plus, Br2 plus 2E minus gives 2 Br minus, and the corresponding E0 cell values are also given. So Tushar, will you please take us through this question?
Okay, first we'll write the half reaction and then we'll write the net reaction.
Alright.
Okay.
Always write the half reaction first for clarity.
Okay. Now it's written oxidation of SN2 by Br2.
Alright.
Hence, there is oxidation of SN2. So this would be SN2 plus would be converted to SN4 plus 2 electrons.
Right.
And if this is getting oxidized, the other substance should be reduced.
Right.
Hence, Br2 would be reduced to 2Br negative.
Right.
From here, we can write the net reaction. These two electrons would be cancelled, and SN2 plus Br2 gives SN4 plus 2Br negative.
Right.
So this is our full reaction.
Correct.
Okay. So the reaction is possible if delta E0 reduction of oxidizing agent is more positive than E0 reduction of reducing agent. But this thing often gets confusing. So I'll tell you a shortcut method for this. If we just need to check, is this possible or not. Hence we are talking about the feasibility for this.
Yeah.
And if we are talking about feasibility, so we just know about delta G, which checks about the spontaneity. That is would the reaction be feasible or not.
Yeah, the Gibbs free energy. Right.
And we don't even require the magnitude of delta G. We just require, would this be positive or negative? We just require its sign.
Yeah.
Hence, it's a very short method which is quite time efficient in competitive exams. So we'll calculate delta G, which is delta G equals to minus NF E0 oxidation plus minus NF E0 reduction.
Right.
Now here n is equals to 2.
Yeah.
And we can take that as common. So we'll take minus n, that is 2
F as common. Yeah.
And we'll add E0 oxidation plus E0 reduction.
Right.
Now these values can be directly checked from here.
Yeah.
So for E0 oxidation, this would be minus 0.13.
Yeah.
As the reduction potential values are given.
Yeah. So the oxidation would be reversed. Yeah. Minus 0.13.
And for E0 reduction, it is directly given as reduction potential. Hence, it would be 1.09.
Correct.
So we just need to add these both values. So it would be minus 2F E0 oxidation plus E0 reduction.
Yeah.
So it's minus 0.13 plus
1.09.
1.09.
Yeah.
Hence we can write it's minus 2F, it's plus 0.96. We don't need to calculate the magnitude of this. We just need the sign, and the sign comes out to be negative.
Yeah. Since Faraday's constant is obviously positive.
As delta G value is negative, hence the reaction is spontaneous. That means the reaction is feasible.
Alright.
Hence, this oxidation of SN2 plus by Br2 is possible.
Can occur under standard state conditions, is a spontaneous reaction. Correct. Now we'll move on to the next question.